in our last tutorial, the ending of the last tutorial, I told you we are going to talk about this particular signal. This signal here, that is the signal generated at the end of this RAM 16, is our assembled timer value. So what is it? The assembled timer value is the RAM 16. This RAM 16. Hope you remember what our RAM 16 is. Let me show you again. We'll be talking about this RAM. So this our typical RAM 16, made of 16D flip-flops. So assuming I have some data here, so it's just our normal deep flip-flop, but I mix it together. Now watch this B is 0. Now watch me clock and see what happens. So B automatically takes the value of A. So what we have here, the RAM 16 is just an assembly of 16D flip-flops. So remember again, we are somewhere around here, the receive control. So remember when we are talking about the transmit control, we talked about this. This is the pulse timer value, and you know it's a 16-bit value. So I know during data reception is broken up into neighbors, and when it's being received, is finally placed together as RS data into 8 bytes. So here, this assembled timer value is going to combine it together back and get our pulse timer value. So let me zoom in more so that you see what is going on there. So we're actually talking of this particular area. What happens here? How the timer value is being combined together, back together. So what does this AND gate do? Our timer value should be at when the byte count is at 17 and 18, because they are the last data we are sending. So it should be, this is 6 plus 6 12 plus 2 14 plus 2 is 16. So pulse timer value should be byte count 17 and 18. That is when we are supposed to receive our pulse timer value. So when the byte timer is equal to pulse is equal to byte count 17 and byte count 18 and our detection windows are on. So this is basically what this AND gate does. So let's look carefully and not get confused. Oh, I'm making this error all the time. Let me see. Oh, what a other error. Mind me, I keep making this very silly mistake all the time. Oh, what can I do? Wow. Okay. So let's watch closely and see what happens here now. So to turn on this first the first multiplexer is the reset. What resets our assembled timer value? The RAM 16 that assembles that TS Pulse TV that we sent earlier. So this bit is the RS start frame. So once ever you start reception, reset this timer value and wait until the byte count reaches 17 and 18. So that is RS start frame marks the start of data reception also. So once the data reception starts and the byte counter starts counting by 1, by 2, by 3, reset this assembled timer value until now. What is the condition for giving it a value? Let's watch this. These two AND gates have a common signal. That common signal, this the one I've highlighted now, is our detection window. Let's go up and see it. Is our detection window. So for you to give it a value to this our assembled timer value, it has to be within the detection window. Yes, quite no problem. Then the next one says, this one down here says byte count equals 17. You see it's 17 and the next should be 18. I've highlighted it also. Next one is 18. So we check it now. It's written 11 in this. Let me check my calculator. So go to X and type 11. So you see it in decimal is 17. Decimal says it's 17. Hexadecimal is 11. So it should be 11 and 12. So that's where it gets turned on. So whenever let me zoom in very clear more. So during the time the first one, we are in byte count 17, the first one comes in, takes the first ROS data at that time. The ROS data we receive at that time is assumed to be the first 2 nibbles or the first byte of our TS pulse TV, our timer value. Then that is when this first one comes on, it takes the first 8 bits. Then on the next byte count, this one comes on and it updates it. If you understand the logic here, it's more like a shifter. You shift the first 8 and now shift the next 8, making it assembling a total of our 16 pulse timer value. So that is how our pulse timer value gets assembled. So we're going to see how we use this pulse timer value. So what next again? So I think this is our delay CLC enable counter. I won't be talking about that. When you read this, you're going to understand everything. So let's come down here. So after assembling the pulse timer value here, this is the place we latch it. So here we already know that for it to take the value, it has to be within the detection window. It has to be that byte count 18, and then that byte count is equal to 18. That is when it has received it truly. So it's now going to take, and when again, it's a problem. After receiving our pulse timer value, is going to latch it in this RAM here. So these are the conditions to latch it. The first one is it has to be within the detection window. The next one is that it has to be at that byte count 18. That is when it has truly received it. And the third one, this our receive pulse form has to be 1. You know, receive pulse form means that MAC address is okay and type length is okay and our opcode is okay. So after checking if all those things are okay, it's going to latch this our timer value here. So can we see what it does with this timer value? Okay, we're going to see that briefly, what it does with this our timer value. But before that, let's check this next subcircuit. I'm trying to make sure that we haven't skipped anything. Let's make sure we haven't skipped anything. Make sure we haven't skipped anything. So we also have our delay CLC counter. I won't be talking about that. We already know how the delay CLC works. Then coming down towards here, what do we have? So this is the last counter we are going to talk about. This is the counter that does the counting of our received pulse timer value. So this counter, you can see here, this is a subtractor. So whenever we receive our pulse timer value, this subtractor here does the decrementing. It pauses the transmission, it pauses data transmission until this our received pulse timer value is 0. So we are going to see how it does that. So what are we seeing? So I think I will explain this from ground up so it will be more understandable. But one thing we have to see here is this clocking. You see that this from here up uses the MRS clock, while from here down uses our MTS clock. So why? Is because we are trying to control our transmitter. Our transmitter is what is actually sending, is what we are trying to pulse, but the receive control signal we receive is from the receiver. So I hope you understand this. The receive control uses the receiver's clock because the receive control receive the pulse, is actually what received our pulse signal. But what the pulse signal is trying to control is our transmitter, because we are trying to pulse our transmitter from pulsing. So once we are done with reception at the receiver, we are going to control the transmitter. So the reason for these two different clock is for synchronization. We synchronize the receiver clock to receive, and we synchronize the transmitter clock to pulse. So this is how finally the pulse was generated. But then again, no matter what we are doing, our register bit must have this bit set, RS flow. No matter what we have, everything up that we've been doing, if we don't have this RS flow set, after all the pulse calculation we've done up here, this pulse won't turn on. So we must go to our register and set this RS flow on. Remember, when we are dealing with the transmit control, you have to set the TS flow on. So now we are dealing with the receive control, the RS flow has to be on. So this is actually the pulse. So this is our pulse signal. So this is from where we were able to generate it. So they said whenever this signal here is not equal to 0 and we have our RS flow on, turn it on. So what actually ons this multiplexer? Let's see. Please be patient so you understand this. I'm trying to find the best way to explain it, so that's why I'm actually starting from the bottom to explain it. These conditions for setting the pulse. So they said you will only pulse it when the current transmission is done, that is TS is done, or when the current transmission is aborted. That is when you can turn on this multiplexer to send your pulse. So you are seeing these conditions. And the third one, this signal must not be on. This TS used data out. Remember, use data out, we used it in our last tutorial. It means when we are not transmitting our own pulse frame, we should not pulse our transmitter. Assuming it's a pulse frame we are transmitting, don't pulse your transmitter. And TS start for frame out. TS start frame out means we are sending transmission. That means for this our transmitter, for us to send this signal, whether to turn it on or turn it off, it must be after a current transmission. If not, it's going to be latched. For this pulse to come on, it's going to be latched. Now let's go up more and see what is happening up here. So this is our slot countdown timer that does the decrementing. So let's see the condition for decrementing. This is the subtractor that decrements after we've received our pulse timer value. This is where it's being decremented. So you know, whenever it gets to 0, this is when this signal goes off. Whenever we've exhausted our pulse timer, it comes on. So let's see what happens here. Okay, that is if our pulse timer value is 0 0 0, this signal comes on and the pulse is off. But assuming we still have a value here, our timer value is still 10 or 25, this should be on, because if we have a value here, assuming this is where the timer value comes out from here, so it compares it with 0. Assuming there is still time left, that means this signal is going to be off. This particular signal is going to be off. But assuming we have exhausted the timer value, that is during the decrementing period, we decremented everything and what we have here is 0. So that means the two of them are 0 0. So this signal here will be on, and if it's on, this is going to be off. Therefore no more pulse. We are now in 0 0 0. But if it's not 0 0 0, that is we have like 10 or 15 timer values still left, this signal will be off and we are still going to be in pulse mode. So that is what he's trying to say. So let's see condition for decrementing. Decrementing comes from this AND gate here. So it first of all tells us that if the timer value is still greater than 0, continue decrementing. It must be greater than 0. It must be greater than 0 from here. And let's see this third condition. So this is a count up timer. What it does is just to count up. It doesn't receive an input. You can see here is inbuiltly latched. Is latched inbuilt. So whenever it counts up to 1 1 1 1 1 1, that is 6 bit of 1, it resets itself. So that is what it's trying to do here. It takes the first 6 bits and see, and then there's also this input here that makes it 7. So 6 bits, when these 6 bits are 1 1 1, remember there's an incrementing here. We call it the slot timer. So once it increments up to 1 1 1, and this 7 signal here is 1 also, then it comes here and causes our pulse timer counter to decrement. I don't know if you understand this. When you go to the code, it's very easy, you'll be able to understand it. And remember also, whenever it's greater than 0, that is if it's still greater than 0, it continues to decrement. If it's greater than 0 and everything here is 1 1 1, including this input here is likewise 1, therefore decrement our slot timer. So that is how the slot timer gets decremented. So then again, let me see. So this is what actually turns it on. Let me show you. This is it down here. If the pulse, now let's see this signal here. If the pulse, if we have a pulse, okay, if we have if we are in pulse mode, and here should be detection, okay, here comes from up, okay, and this one, this should be RS flow is on, therefore go here, come here and keep incrementing. So that is the condition for incrementing this timer. It's different from this is the main timer here, and so on. So when you go to the code, everything is quite very understanding. If you go to the code, you'll be able to understand. With the little explanation I've given here, you understand everything. Please kindly subscribe to my YouTube channel. Thank you.